The universe is a ceaseless fractal, made basically out of an endless number of limitless effects known as immaterial immense bangs. Assuming you consult the science coursebook distributed before 2006, you will see that Pluto was categorized as one of the 9 planets in our planetary framework. However, this is no longer the case. Around 10 years ago, the International Astronomical Union, IU, renamed Pluto's status and barred it as a planet. Yet again, the IU is discussing this issue since NASA has provided clear pictures of Pluto, which is now classified as a dwarf planet. Join us on a journey to the farthest reaches of our planetary group to explore the first pictures of Pluto in our history. If you're keen on staying informed about news from the universe and its mysteries, subscribe to our channel, like this video, share it to reach more individuals, and turn on notifications. We've made significant advancements since the historic Apollo 11 mission. However, the vastness of space presents an enormous number of unanswered questions. This is where NASA's ambitious James Webb Space Telescope project aims to explore its unique, vast expanse. This astounding mission builds on NASA's previous work and has sparked great interest in interpreting remarkable discoveries from ancient times. We are naturally curious about the Big Bang and how our planetary system came to have life on one of its planets. The James Webb Telescope, however, has its sights set on the future of our nearby planet group, revolutionizing our understanding. Although it is vital to decide whether we need to look back for convincing answers about our universe, perhaps we must also adjust our understanding. The Pluto debate has been a subject of contention in the field of space exploration. Thanks to the fascinating discoveries of the James Webb Telescope, the issue of Pluto's status remains unsettled. The sharp, initial pictures of Pluto provided by NASA are transforming how we interpret celestial history. The first and primary human encounter with Pluto was driven by the New Horizons mission, which has been ongoing for many years. In July 2015, the mission achieved its goal by passing near Pluto and its moons. This was when people first had the opportunity to closely examine the space object and gather the most complete dataset to date about its moons and surface. The New Horizons mission opened extraordinary opportunities for NASA in its exploration of the Kuiper Belt, a distant region of space. The mission's primary success was the detailed exploration of Pluto, now considered a dwarf planet, and its largest moon, Charon. It also managed to capture clear images of 4 other satellites known as Nix, Hydra, Kerberos, and Styx. Over 15 months, the mission collected data amounting to 6.25 gigabytes. How does this data affect NASA's perspective on the dwarf planet? First, the discoveries were so remarkable that researchers had to develop new data models to better understand Pluto's surface and atmospheric conditions. It was noted that the dwarf planet was undergoing massive changes in its surface and atmosphere. It was clear that Pluto was far from being a dormant body. It was evolving at a surprising rate, challenging past beliefs about this putative planet. The New Horizons mission was pivotal. Its encounter with Pluto nearly 10 years ago marked a turning point in the history of space exploration. Since then, the field has witnessed dramatic updates through technological advances. With the addition of the James Webb Space Telescope, the possibilities are becoming endless. One could say that we are steadily approaching a comprehensive understanding of our solar system. However, there is an issue with missions like New Horizons or endeavors to explore planets farther from the Sun. Resource prioritization. Spending millions to study a potentially significant planet raises questions about the existence of possible life elsewhere. Why venture to the edges of the planetary system? These are pressing questions. Regardless, the New Horizons mission marked a milestone in space exploration. Not only did it open new avenues for NASA to invest in studying Pluto, but it also fueled our interest in further exploration beyond known boundaries. Studying Pluto is essential for building a broader scientific understanding of other small planets. Despite its location in a cold, dark region of the universe, the initial images of Pluto's surface were significant enough to reveal that Pluto is an active object in our local planetary system. As the saying goes, a picture is worth 1,000 words, and these high-resolution images from NASA provide us with valuable information. For instance, Pluto was found to have a heart-shaped feature, scientifically known as Sputnik Planitia. Surprisingly, Pluto literally tilts on its heart. A glance at NASA's high-resolution images revealed that this heart is a white, nearly frozen left ventricle of Sputnik's heart. It resembles a massive nitrogen glacier spanning thousands of square kilometers. Another striking feature of Pluto's surface is the axis of its rotation, which has undergone significant reorientation, a process scientists call a precession cycle. This was unknown to NASA before the mission. The dwarf planet's bowl is in an unexpected position, with profound implications for understanding Pluto's dynamics and evolution as a planet. Simply put, the rotational axis between Pluto and its moon, Charon, is influenced by Sputnik Planitia, the core of the dwarf planet. This interaction has reoriented Pluto so that its axis aligns more closely with its rotational axis, something not previously understood. Scientists also discovered that Pluto has a subsurface ocean beneath its thick ice sheets and frozen surface. This discovery is crucial for several reasons, most notably because it fundamentally changes our understanding of the planet. The potential presence of a subsurface ocean on Pluto suggests new insights into its origin and formation. The presence of a liquid ocean beneath Pluto's frozen surface raises questions about what constitutes a habitable environment beyond Earth. It prompts us to rethink the dynamics of celestial bodies in the farthest reaches of our planetary system. This ocean, estimated using gravitational data and supported by findings from New Horizons, represents a potential reservoir of liquid water beneath a frozen crust. Understanding Pluto's geological cycles is critical for grasping its evolution over billions of years. The dwarf planet's surface features, including its distinctive heart-shaped region and the surprising reorientation of its axis, offer fascinating insights. Sputnik Planitia, the heart's left ventricle, is believed to have formed due to a subsurface ocean freezing and causing the surface to collapse, or possibly due to an impact that exposed material, creating a deep depression. The New Horizons mission's encounter with Pluto in 2015 unveiled a wealth of discoveries that continue to reshape our understanding of this enigmatic dwarf planet and the solar system as a whole. The New Horizons mission revealed Pluto as an unexpectedly dynamic world. Observations showed that Pluto's surface is far from static, with evidence of geological activity and shifting ice masses, especially in the Sputnik Planitia region. This vast nitrogen ice plain is bordered by rugged mountains made of water ice, a combination that suggests the planet's surface is being reshaped by internal and external processes. Further analysis showed that Pluto's atmosphere is thin but complex, primarily composed of nitrogen with traces of methane and carbon monoxide. It interacts with the surface and is influenced by the dwarf planet's extreme seasons, which span over hundreds of Earth years due to its elongated orbit around the Sun. One of the most surprising findings was the possibility of a liquid ocean beneath Pluto's icy crust. This discovery has significant implications for astrobiology, as subsurface oceans are considered one of the key criteria for the potential existence of microbial life. While there is no direct evidence of life on Pluto, the idea that it might harbor a liquid ocean challenges preconceived notions about where life could exist in the universe. Pluto's moons, especially Charon, have also drawn significant attention. Charon's surface is marked by massive canyons, ridges, and plains, suggesting tectonic activity in the past. Its reddish polar cap, likely formed from methane escaping Pluto's atmosphere and freezing on Charon, adds another layer of complexity to the Pluto-Charon system. The discoveries made by New Horizons have led scientists to question the criteria used to define a planet. The International Astronomical Union (IU) demoted Pluto to dwarf planet status in 2006 based on its inability to clear its orbit of other debris. However, many astronomers argue that this definition is too narrow, and new data from missions like New Horizons may prompt a reclassification in the future. The James Webb Space Telescope (JWST) has further expanded our understanding of Pluto and other distant objects in the Kuiper Belt. Its ability to capture high-resolution infrared images allows scientists to analyze the chemical composition of Pluto's surface and atmosphere in unprecedented detail. Beyond Pluto, the Kuiper Belt remains a treasure trove of information. It is a region populated by icy bodies and remnants from the early solar system, offering clues about how planets and other celestial objects formed billions of years ago. By studying this region, scientists hope to uncover the origins of the solar system and possibly identify other ocean-bearing worlds. The exploration of Pluto has also sparked renewed interest in sending future missions to the outer solar system. Proposals for orbiter missions or even landers on Pluto are being discussed, with the aim of studying its surface, atmosphere, and subsurface ocean in greater detail. Such missions would provide a deeper understanding of the processes shaping this fascinating dwarf planet and its role in the broader context of planetary science. As we continue to push the boundaries of exploration, Pluto serves as a reminder of the complexity and wonder of our solar system. Its dynamic nature, intriguing features, and the potential presence of a subsurface ocean make it a prime candidate for further study. The data gathered so far has not only deepened our understanding of Pluto, but has also inspired new questions about the nature of planetary systems and the potential for life beyond Earth. The journey to Pluto, once considered the distant frontier of the solar system, has proven that even the most remote worlds hold secrets waiting to be uncovered. With each new discovery, we inch closer to answering some of the universe's most profound mysteries. One of a kind, a world nowhere near the cold and lethargic body it was once remembered to be. The mission caught nitty-gritty pictures of Pluto's assorted scene, including mountains made of water ice, huge fields of nitrogen ice, and districts with complex designs looking like cell organizations. These highlights recommend dynamic land processes, perhaps determined by interior heat sources or connections between surface materials and Pluto's slender climate. Pluto's environment, slender compared with Earth's, assumes an essential part in its surface. It basically comprises of nitrogen with hints of methane and carbon monoxide. During Pluto's curved circle around the Sun, these unstable gases sublimate from its surface, making transient climates that change with occasional varieties. Understanding these air processes helps researchers recreate Pluto's climatic history and its continuous advancement. The New Horizons mission's revelations stretched out past Pluto itself to its arrangement of moons. Charon, Pluto's biggest moon, uncovered an startlingly fluctuated scene, including a huge cavity bigger than the Grand Canyon and a dull district nicknamed Mordor for its particular shade. Other moons, for example, Hydra and Nix, showed unpredictable shapes and cratered surfaces, demonstrating a set of experiences set apart by influences in land activity. NASA's investigation of Pluto and its moons addresses humankind's continuous mission to investigate and comprehend the tremendousness of our planetary group. Each new revelation brings up additional issues about the starting points, advancement, and variety of heavenly bodies, testing existing speculations and provoking scientists to grow new models and speculations. Past its logical importance, Pluto holds social and representative worth as a far-off boondocks that mankind has reached and investigated. The photos and information returned by New Horizons have dazzled individuals all over the planet, starting minds and reviving interest in space investigation. The mission's prosperity highlighted the significance of assurance and development in pushing the limits of human information. Looking forward, NASA's James Webb Space Telescope vows to additionally change how we figure out Pluto and other far-off objects in the Kuiper Belt. Intended to send off in 2022, this best-in-class space observatory will peer further into the universe than any time in recent memory, utilizing its refined instruments to concentrate on the climates, organizations, and elements of planetary bodies like never before. The James Webb Telescope's capacities stretch out past noticeable light, permitting it to recognize infrared radiation transmitted by objects in profound space. This capacity is essential for concentrating on cold, faint items like Pluto, whose frail outflows are challenging to catch with customary telescopes. By investigating the infrared marks of Pluto and its moons, researchers desire to acquire bits of knowledge into their surface pieces, geographical movement, and surprisingly, potential indications of organic atoms. One of the essential objectives of the James Webb Telescope is to examine the starting points of planetary frameworks and the circumstances that prompted the arrangement of tenable universes like Earth. By concentrating on objects in the Kuiper Belt, including Pluto and its neighbors, stargazers intend to unwind the secret of how little cold bodies came together and developed in the early solar system. These disclosures could give signs about the predominance of water and natural mixtures in other planetary frameworks throughout the universe. The innovative headways made conceivable by missions like New Horizons and the James Webb Telescope are making room for future investigation of the external solar system and beyond. Proposed future missions incorporate orbiters and landers intended to concentrate on Pluto's surface more intently, gather tests, and even search for indications of microbial life in its subsurface sea. The quest for life beyond Earth is a focal subject in planetary science, driving researchers to investigate assorted conditions and evaluate the possible livability of divine bodies. While Pluto's surface circumstances are cruel and cold to known types of life, the revelation of fluid water underneath its cold shell raises charming conceivable outcomes. Comparative subsurface seas could exist on other cold moons in the external nearby planet group, for example, Europa around Jupiter and Enceladus around Saturn. Concentrating on Pluto's subsurface sea could give bits of insight into the circumstances essential for life to arise and flourish in outrageous conditions. By analyzing the synthetic organization of water and minerals in the sea, researchers can survey its capability to support microbial life or preserve proof of past organic movement. Future missions, furnished with cutting-edge mechanical innovation, could bore through the ice to get to the sea and search for indications of something going on under the surface. The investigation of Pluto and its moon system also adds to how we might interpret planetary defense against potential space rock impactors. Objects in the Kuiper Belt, including Pluto, are leftovers of the early planetary system and can offer significant experiences into the recurrence and nature of effects that molded planetary advancement. By concentrating on influence holes and surface elements on Pluto and its moons, specialists can reproduce the history of astronomical crashes and evaluate the dangers presented by near objects. NASA's planetary protection endeavors mean to identify and track possibly risky space rocks and comets that could represent a danger to Earth. By considering the attributes of the Kuiper Belt and different districts of the planetary group, astronomers can work on their capacity to foresee and moderate effect risks. Future missions to Pluto and other Kuiper Belt objects will add to these endeavors by extending our insight into divine elements and the land processes that shape planetary surfaces. In expansion to logical examination, the investigation of Pluto brings out wonder and interest in the universe. The pictures and information returned by space missions catch the creative mind of individuals overall, fostering a feeling of stunningness and appreciation for the excellence and intricacy of our nearby planet group. As mankind proceeds to investigate and expand how it might interpret the universe, each new revelation carries us closer to revealing the secrets of our cosmic starting points and our place in the universe. The investigation of Pluto and its moons typifies the cooperative nature of space exploration, with researchers, engineers, and specialists from around the world cooperating to accomplish aggressive objectives. Worldwide associations and organizations improve our capacity to lead complex missions, share information, and advance logical comprehension for the advantage of all mankind. By pulling resources and expertise, space offices can handle challenges that would be hard for any single nation or association to address. Looking forward, people in the future of researchers and adventurers will build upon the establishment laid by missions like New Horizons and the James Webb Telescope. Advances in innovation, counting artificial intelligence and independent robotics, will empower more refined missions to explore far-off worlds and unwind the mysteries of the universe. The continued exploration of Pluto and its moons, alongside other distant objects in our solar system, will undoubtedly contribute to shaping our understanding of planetary science for generations to come. Each new discovery helps us piece together the vast puzzle of our solar system's history, its formation, and the diverse environments that could harbor the conditions for life, whether past, present, or future. As space agencies around the world continue to collaborate, Future missions will not only focus on the scientific aspects of planetary bodies like Pluto, but will also have broader implications for space exploration. By studying the chemistry and geology of distant worlds, scientists hope to gain insights into Earth's past, present, and future, ultimately answering profound questions about our own planet and its place in the universe. Moreover, these missions offer the potential for breakthroughs that could change our understanding of the nature of life itself. With the potential discovery of microbial life in extreme environments like Pluto's subsurface ocean, there could be far-reaching consequences for the search for life beyond our planet. Such findings could spark a renewed interest in the quest for extraterrestrial life, prompting new research efforts and technological advancements. The role of technology in these missions is undeniable. As instruments like the James Webb Space Telescope push the boundaries of our observational capabilities, the search for answers will extend beyond the immediate boundaries of our solar system, allowing us to investigate exoplanets and other stellar systems in the quest for Earth-like worlds. These advancements may one day lead to the discovery of habitable planets that could one day serve as future destinations for humanity. In essence, the study of Pluto and its moons is more than just a scientific endeavor. It is a testament to human curiosity, ingenuity, and the quest to understand our place in the universe. As we venture deeper into space, the boundaries of knowledge and exploration will continue to expand, inspiring future generations to push beyond what we thought possible, ensuring that the spirit of discovery remains a core element of human progress. In conclusion, Pluto, once seen as a distant and isolated world at the edge of our solar system, has become a focal point of scientific inquiry and a symbol of the endless possibilities that await in the uncharted regions of space. Its mysteries, its potential for life, and its status as a cosmic frontier will continue to inspire awe and wonder in those who look up to the stars, driving us to explore further and to seek answers to the greatest questions of our existence. The story of Pluto is far from over, and the future holds even more exciting revelations waiting to be uncovered.